Do a sequence and series problem where we handle inserting n means within two numbers. So the question is, if n arithmetic means are inserted between 0 and 32 such that the second mean is 1/7 of the n minus 1 mean, find the value of n. So the options given are as follows. So before we get to the solution, the key here is that they are talking about the mean, which is another term in the whole arithmetic progression. So you need to look at it as 0 as the first term and 32 as the last term, and then there are going to be n terms in the middle. That is the goal here. So let's see how we get to this answer. So we have n arithmetic means between 0 and 32. So the second mean, which is going to be the third term, we know that that's basically a plus n minus 1d, right? So that is a plus 2d. So we know that. So we are interested in the second mean and the n minus 1 mean because they have a relationship. So then moving on. So a is 0 because that's the first term, and so hence the second mean is 2d, 0 plus 2d. And then the n minus 1 mean, and here is where it is tricky, is that you need to look at it as that n terms are inserted. So there are n plus 2 terms, right? So 32 is the last term. So the previous term is the nth mean. So the previous term is, since the common difference is d, it's 32 minus d. The two terms before that is the n minus 2 term, but it is the n minus 1 mean because n means were inserted. That's the very key thing, that n means were inserted, but the total terms are n plus 2. So, because we had to include 0 and 32. So, 32 being the last term, so that makes it as 32 minus 2d, because we are going 2 steps back, and d is the common difference. That makes the n minus 1 mean as 32 minus 2d. Now we have been given a relationship between them that their ratio is 1/7. So we do that 2d by 32 minus 2d equal to 1/7. It's one variable. We solve for it and we end up with d equal to 2, right? So now we have to just find the we have to find n. So now we know very well the 32 is the n plus 2th term. So 32 is a plus n plus 2 minus 1d, because that's the total number of terms. You remember the formula is AR equal to a plus n minus 1d, but that's for n terms. Here we have n plus 2 terms, so we substitute n plus 2 there, and now we solve for it, and we will get n as 50.